Hey, how's it going, everyone? We're going to be doing Pytorch today. We're going to be predicting where the user is going to click on the screen. Thank you to Quantified Quantum for setting this up for us. We had the base game. As you see here, we got the base code already. None of the AI is there, and we're going to add in the AI part, and we're going to see if we can make something work. I don't know. It's not a lot of data, and so we'll try to do reinforcement learning. Very small amounts of data. So are we going to get it to work? I don't know. We'll find out. We'll see if we can build the model, and we'll see how far we get. We might not finish it today. We might not finish it. We'll see how far we get. All right, let's see. Let's jump over to here. Get some notes set up. 1 second. Okay. Whoop. Nope. Yep. Okay. All right. All right. So we've got our. Actually let's do this. Let's open this first. So let's run this game. Game Python main. That should work. Okay, great. Okay. So we've got our main canvas here. Some circle in the middle for some reason. And then we can see where we're clicking. This is kind of neat. I like that. Good start. So what we need to do is capture these inputs, which are being captured into a list right now. I do believe it's a list somewhere. There's a list in here somewhere. And it's storing all of these click positions. So this should be the maximum, near the maximum corner here. Let's see here really quick. Hey, popped in here. Hey, SAQ3000, how's it going? We're doing Pytorch today. Quantified Quantum set us up with this Python class, the base class. A really simple application, and it lets you click on the screen. And what we need to do is have an AI predict where you're going to click next. So we need to think this through. We got to think this through the right way, because if we click and then we immediately show where we think the user's going to click next, then you've essentially predicted the future and you've changed the course of things, because you've showed the user where the AI thinks they're going to click, and they're just going to go somewhere else. So like if you click here, but the AI thinks you're going to click there next, and you show both of the dots, it's a problem, right? Because you're changing the future at that point. So we need to hide it until the user clicks. So we need to click, and then the AI also needs to simultaneously click with where it thought that it was going to be clicking next. So we're going to see if that works. I'm messing around with Neo 8M GPS module. What is that? SAQ3000, what is that? Tell us more. Tell us more about it. What is it? All right, let's see here. Let's close. All right. And then we will, let's see here, close that. Okay, so let's get our Pytorch going here. So import Pytorch, and we're probably going to do a simple, there's nothing advanced or complex here because this is simple vector in, vector out. I would like to transform it so that we normalize it. I would like to have a normalization step. Okay. Pytorch, and then import, let's see here, or it's not Pytorch, it's called Torch. And then, let's see, from Torch, import neural network. Yo, how's it going? Balian, what's up, bro? Today we're going to be doing Pytorch. We've got this game here. Well, it's not really a game. It's more, we're going to try to predict the future is what we're going to do. We're going to predict where the AI is going to predict where the user is going to click next. So we're going to see how far we get. I don't even know if it's possible because it's a small amount of data. GPS module that allows you to see GPS. Oh, nice. Okay. Looks forward to do a war walking or a war driving. Walk around and capture signals around you, basically. Okay. Nice. Reckon for short. All right. So that's pretty neat. Okay, so you've got a module that's able to capture signals from the satellites, the GPS satellites, and then you coordinate. You get 4 signals, and then you get your location. A semicolon is the difference between a working app and a mental breakdown. Carmu, you're right. Sometimes it is. Very often it is. You're absolutely right. So let's see here. Let's see, Pygame. Is it good? Okay, here we go. So what we need to do is we need the AI to simultaneously predict where it thinks the user was going to click. So in order to predict the future, if the user, we need to capture the first click, and then the second click, we need to show where the AI predicts and where the user clicked. I think that's what we got to do. Otherwise, it's going to be a problem. It'll be a problem because the user will see exactly what we didn't want them to see. Well, walk around and find where the signals are coming from. Triangulation. Yeah, triangulation. Because with the GPS, don't you need like 4 signals? I think you need 4. I think 3 is enough, right? You get 3 enough, though you get a better resolution if you get 4, like a dramatically better resolution. Let's see here. All right, so we want neural network, and then we're going to want to set up our module. So let's see. We'll try to copy. We'll try to copy this format here. All right, here we go. We'll call this the predictor, and then we'll have the model. We also need the optimizer, and we can copy. Can I have a mod? I subbed. You subbed. Aiden. Hey, how's it going, Aiden Harris? Good to have you, and you subscribed. All right, so you are asking for a mod. You want mod. You want mod on? Sure, why not? Okay, let me see if I can click some buttons over here. Let me figure this out. One moment. We'll get this going over here. Clicking buttons, and then there we go. Well, I can't store 3 GPS modules. Oh, you don't need 3. You need just 1 module. You just need to capture 3 separate satellite signals, right? From 3 independent signals. You get the ID and then the time. There's a time slice of some sort. I forgot how it works. I forgot specifically how it works. All right. Activity go, pin, remove, add, moderator. All right, here you go. There you go. All right, Aiden. All right, did that work? Did that work for you? All right, so what I need to do is I need to go back to my reference file. So let's go project/projects, AI game. I think, let's see here. It would be game.py. Perfect. Okay. So we got Pytorch. We need to grab this. Where's my AI at? So we already have some stuff that we could just copy and paste from a previous project. Here we go. This is what I'm looking for. There we go. Optimizer, loss. These are good. Those are good. Features, labels, outputs. I don't think we need this information. We do need learning, though. We want the learning rate. I want the learning rate here. And the model, where's the model at? Will be just none for now. Okay, perfect. Excellent. There we go. Hey, how's it going? Nidik, how's it going, Nidik? Welcome on in. We're doing today Pytorch to get the AI to predict where the user is going to click next. Is this the right? Did I do that right? Yeah, I did that right. Okay, so this is good. Okay. Do we need that? We do want to bring that back. We'll bring that back in a second. Hey, Stephen, good morning. How's it? Kamala, good to see you. Welcome on in. Happy to have you. Good morning. We're doing some AI today. Quantified Quantum so graciously gave us this base file, and we're starting to mess with it right now. We already started to open it up. So we added a predictor class, and the idea is it's going to predict where the user clicks next. We're gonna have to try some things out. Maybe some. We'll see here. I'm trying to think of some ideas. There's a lot of things. There's a lot of different approaches that you can take here. So I'm gonna try my best. Okay. Here, bring this back. I do want to open up the project that we had previous to AI game.py. Not that one. Game.py. There we go. Okay. /opt. We want to. There we go. All right. So we need to instantiate it, and we need to copy and paste some of these ideas here. Did you know about Flipper Zero? I didn't. What are you doing? Oh, we're building an AI that can predict your clicks. It's going to predict, you click one spot, and the AI is going to predict where you click next. That's the idea. The rotation of the Earth really makes my day. Does it? Well, yeah, it does. It sure does, doesn't it, Karu? Otherwise, there would be no day to make. Because it would be a static Earth. Data collect? Wait, what do you collect? Oh, cool. All right, cool, yeah. There we go. All right. So, we've got this. Did we want to do anything? I guess we could track this. Here we go. Yeah, we want to track those things. So we could track losses, which is going to be a list. Where is that? We could do, here we go. No. Where was that at? I guess we could just say list. We'll just say list is what we'll do. Here we go. Grab this, colon, list. Can I do it like that, or do I have to do it like that? It turns pretty colors when I say it like that, so we'll try that. All right. Let's see here. Where are we going to go from here next? Okay. So I want to instantiate this. This is probably in the main file. Or in the main function here. So let's go to main. And then pygame. So how should we, we should do predictor equals predictor. Wait, I have two spellings here? Predator. Wait, did I spell that wrong, or is that just something else in here? What is that? Oh, that's just coming from my other file. No worries about that. Predictor. Okay, perfect. Excellent. All right, looking good there. Okay, so I want optim. There we go. Okay. Losses, going to be that. What else? We need more. The learning rate. We'll just leave it there for now. We'll leave it there for now. We don't need this. And the model needs to be set as well. Or is it? No. I think we can do this. I think we can figure this out. All right. So losses list less model. Okay, perfect. And it is going to be something like this. I think we could probably do something like this. Let's see here. Model. Sequential 10H. Yes, because we're going to do, it's basically exactly the same thing that we did in our previous game where the AI was tracking user coordinates. So with the user coordinates, we want to use a similar model here. But the input is just going to be 2. Wait, no. We could do a lot more than 2. We could do multiple things. We can track before they click if we wanted to. We could also track every click in a sequence, which I think might be better, although we'd need more data because it's a larger input. So maybe what we could do is do 6. So we track last 3 click positions, right? So I think that's what we do. That's why it is. So it's XY, XY, XY. Multiple XYs. Let's see here. Steven, take a YouTube search yellow purple. I don't know about that. What do you mean by that? Like I don't even know what that is. All right, so I'll do it. YouTube. We'll see what that does. Well, I don't know. I'll bring that up on stream. You never know. Don't know what that will show up. All right, so you said yellow, purple, PURPLE. I don't know about this. Wait. It's just yellow and purple colors. Is it something else? Wait, what do you mean? I did a YouTube. Here's what the YouTube search looks like. There you go. It's just the colors, and it looks like paint colors. It looks just like paint. Hey, Kyle, how's it going? Unique X Kyle, how's it going? Good to see you. We're doing AI today. Yes, the first one. Oh wait. Oh, I just closed it. Here, let me open that back up. Boop. All right. The first one. This one here. Oh, okay. Is this what you want? Is this what you want? Why are you looking? Oops. No, they're Hearth Symbols channel. Not that one? Okay. Hearth? I don't get it. Send it on Discord. Send it on Discord so then I can click the right one. Is this a game? Oh, Aiden. Nah, not really. I mean, it's not really a game. All right, so let's use Python. Here we go. So not really a game. All right, 1 second. Model equals model. Let's make sure that works there. And that should pop up just fine. That should be pop up. So it's not really a game. So what we're going to do is we're going to be clicking around, and then the AI is going to make predictions where the user is going to click next. So it's more of a reinforcement learning stream is what we're doing. Up first one. I clicked on the first one. Hello, just wanted to say hi, Eddie Legendary. Thank you for saying hi. Good to see you. There was there it was. I can see it. There was hearth-shaped symbols, yellow and purple, the channel. I'll try one more time. All right, one more time. Hearth. I don't see how that... I don't see it. I don't get it. Knit the video, the channel. You didn't click it. Yeah, I know I didn't. I didn't, obviously, because you'll have to send it in Discord. You'll have to send it in Discord because I still don't see... I don't see anything that looks like a hearth. Because a hearth is something that goes around a fireplace. You said hearth. Did you say heart? Like a heart shape? Because this is kind of heart-shaped right here. Bro, the first hearts burst up. Oh, this. Okay, gotcha. Okay. Oh! I'm getting it now. All right. You were talking about this before. You were talking about the flipper. Okay. Right. Yeah, okay. So a microcontroller that's able to do Wi-Fi. Well, you can interact and do fun things with Wi-Fi. I don't know, some fun things, right? Fun things with Wi-Fi. I know what you're talking about. I know what you're talking about now. All right, let's see here. W, okay. All right. That was it. Okay. Speaking of fireplaces, right? Hearth, right? I was about to go chop wood. Saw you streaming. All right, Kyle. Nice. It's the time of year where chopping wood happens. By the way, a big scary robot, Enard, he posted a part 2 of the self-aware robot. That sounds scary. DIY Flipper Zero. That's what it is. Nice. SAQ 3000. That's awesome. That sounds concerning, Eddie Legendary. I'm concerned. Okay, so we've got our model. Torch looks good. Multiple inputs. And then we've got our loss. We've got our optimizer. Okay, with the models, parameters, good. MSE loss, when you calculate loss. Okay, perfect. Okay. So now what we need to do is we should run the data through our model once. I think we could do that. I think we can do that. Okay. Let me close that. Let's bring it up over here so it's a little bit easier to deal with. Yes, there we go. Excellent. Okay. Steven, Aiden, what is my name? Steven. My name's Steven. Or are you talking to someone else in chat? Let me know. My name is Steven with a PH. Steven PH. Okay. Let's see here. I want to go where the data is captured, which is going to be around here somewhere. Okay. Self event. What is this? Okay. Point marker. All right. So we should be able to get the point list. We should be able to see what the point list is. So the point marker is defined. Markers here. Okay. So in the game loop, which is going to be here, this is the game loop right here. We need to capture the current marker state. That's what we want to do. Is capture the marker state. Stephanie? I mean, it's really close to Stephanie. It's not far off. Steven's going to predict the future with AI. That's actually pretty much what we're doing right now. That's what we're doing. Let's see here. How long did this take you? Aiden, we just started. We're just getting started. So a few minutes, like 19 minutes, let's say. I can send the video in Discord. Yes, Eddie Legendary sounds great. Though I don't know if I want to watch all of it because I have concerns. Steven's AI is reading minds. It basically is. That's basically what we're going to do. So we're going to have a map marker, going to capture user input, user clicks, right? User clicks or user touch on the screen, and predict the next location where that's going to occur. Was just wondering if we can predict the future with AI. That's what AI basically is doing. It's basically predicting the future. It is a future predictor. It does pretty good. It does pretty good. Okay. All right. So now we've got the map marker, and the marker is going to have like a point list, I believe, around here somewhere. Where is this? It's called point list, like this. Okay. So it's going to be marker.pointList. Marker.pointList, like that. And we want the last 3, I believe, is what we're looking for. So this will be the features. Wait. And the label. Hold on a second. Wait. We need some help here. I need some help. Python. All right. Python. All right. So let's do this. 0, 1, 2, 3, 4, 5, 6. Okay. Psycho Mantis from Metal Gear Solid. I remember that. Oh, that was so on the PlayStation. That was a wonderful game. Oh, I love that. I played that game so much. That was a great game. Kyle. Oh, I love Metal Gear Solid. Metal Gear Solid. So good. It was fantastic. All right. So if we do -3, it's just going to be the last. Oh, is this going to be? Okay. So we need to colon this. There we go. So that's the first 3. What if we did it like this? Okay, that's what so what if we, what would that look like? 1, -1. Okay, so -4, -1, which gives us the 3 last clicks. And then, so that's what we need. That's what we need. So this will give us the features. Paste. And then the label will be the last position, -1. I think just like that, right? So we could do that, just -1. Yeah, perfect. Okay. So we need to, we can't start training the AI until it's got enough clicks. So you need to click a bunch first. So that's part of it. I'm married with a bunch of kids. Nice. Well, I mean, there you go. All right. So one second. What was I thinking here? So we need to, I want to make a function. What are we doing today, Mohammed? We are making an AI that can track user clicks and predict them. So here you go. So Quantified Quantum built a clicking app, right? So it's a clicking app. And what we want to do is have the AI predict where it thinks the user is going to click next. One of the things, like from a deterministic perspective, is that we can't show, when a user clicks, we can't show the immediate next click, because that's going to influence where your next click's going to go. You're obviously not going to click where the user thought you were going to click. So he's making a Psycho Mantis IRL, pretty much. It is, right? Because of the user inputs. Remember on the PlayStation when you had I remember this, like you had your controller and you'd be playing, but if you moved your controller to the player 2 slot, right, the player 2 controller, then Psycho Mantis couldn't read your movements. He couldn't read your movements. You remember that? That was fun. That was a lot of fun. That was really neat. That was hard to figure out, obviously, because it's something you never do. They had a lot of fun with that game. They made that game. That was like a groundbreaking game. All right, so we've got all of our clicks here. Okay, bring it back over. Okay, so we need to. I want to make this into a function. Let's do predictions. We'll make this a function, and we'll send in the marker. So that's what we'll do. Predictions and markers. So we need to def predictions, and we need a marker. There we go. And it's going to have this data here. Excellent. Nice. What we need to check to see if it's long enough yet. Otherwise, we have to pass. We have to pass. So if, let's see, do points equals. So that way we keep things nice and tidy. There we go. Points. If points len greater than 4, then we can. Oh, actually, I have an idea. Let's do this the opposite direction. I like to keep things clean, so let's do return like this. If points are less than 4, then book it. Quantum be cooking. I know, right? Quantum did a great job getting this set up for this, so we're making it happen now. Okay, so we've got our predictions. We'll leave if there's not enough points. And then now we've got our training data, right? The environmental data. We've got the environmental data. So we then can do okay, so let's see your features. Where's that at? Okay. Labels. All right. Sounds good. Features, labels. Okay. Right. So we have all the features all defined, nice and good. We need to normalize it. So one thing I do want to try Aiden BRB. All right, sounds good. One thing I want to try is getting a full native Pytorch pipeline, including the transform. So that way we can compile it and not have a broken graph. Something that I've learned, because we've been breaking the graph this whole time, because I come from a world where I don't use a framework like Pytorch. If you do use a framework like Pytorch, they want you to use all of their internal system tools and their manipulations of your matrices. If you do that, you can compile it and you can even export it. So that way it is a fully capable neural network, including all the encoding and decoding steps, all in one. And so I've been doing all that manually outside of the graph. It won't be exportable if you do that. Well, technically you could, but then you have to re-implement all of the encoding and decoding layers when you do that. So I want to make it, this is like my goal for this stream. This time around, we're going to be creating a complete unbroken graph in Pytorch. So that's the plan. So obviously you're seeing right here, this is a broken, right? So we've broken the graph here because we're doing our transformations outside of the model. And so I want to do the transformations inside the model. That's what we're going to do. So we should be able to do just, where's predictions, marker. We also need the model and the marker. Okay, model, marker, model. Perfect. Okay, I think that should be fine. I think we should be good with that. Let's see. Or predictor. We want the predictor, actually. Let's get the predictor in there. I think that's a better idea. Not the model itself. We want the predictor. Okay, where is this at? It should be around here somewhere. Here we go. This is what I'm looking for. Excellent. Excellent. Okay. Let's do this. Let's do it at the very bottom. We'll do it at the very bottom. So that way we get the most recent data. Or wait. We don't want to do it there. We want to do it here. Before, because what we can do is we can also draw, and it needs the game as well. And wants the game. Okay. When the user clicks, we want to draw the predicted circle as well. By the way, Synth the Self-Aware Robot Part 2, Eddie Legendary. All right. I don't know if it's this really scary. It's really scary. We'll check it out. All right. So that'll be something that we do maybe here in a little bit. We'll do it in a little bit. All right. That'll be the plan. Just in a little bit. Because I'm kind of figuring this out. Okay. So we got a predictor. Not enough. Leave. I would like to say, see, do we have any prints in here? Print. We do have some prints. Okay. So go print. Are you on Twitch? Yeah. Aiden, I am. We're on Twitch now. We're on Twitch. Yep. YouTube and Twitch. We're on YouTube and Twitch. I've been trying the clock app. Please run. Oh wait, run where? Ashton, where are you thinking of running? What are you thinking of running? All right, so we are. Let me see here. Let's see. We need 4 clicks. All right. Training. Let's see if we've got something that works now. Let's see if we get something that's looking good. Okay, sounds good. Please run. Wait. Where do you want me to run? Okay, so 1, 2, 3, 4. All right, looks good. No errors. All right, we're in a good spot. We're doing good. We're doing good. Not M4R. I'm thinking about software. Help FPS frames per second players to fire more precisely by assisting them with moving the cursor. Assisted gaming, like I don't know, aim bots. It works with mouse PWM signals and is implemented as a third-party hardware. Yes. You absolutely could do this, and here's the deal though. The game developers are still able to track your capabilities and see if you have such a high score and such a high accuracy, right? That the hardware and the input when it updates your mouse cursor needs to have some offsets and some randomization. Otherwise, you're going to be marked as a cheater. So it is possible, and it's possible to get around that. So you kind of have to, please pronounce again my name. Oh, wait. Ashootosh? Oh, wait. I said, all right, sorry, it's Ashootosh. Is that, Ashootosh? Am I saying it right? I'm not sure. Let me know if I'm saying that right. Okay. Hey, Finn Wolf. How's it going, Finn Wolf? Good to see ya. Finwolf Hard the Stranger 27 is here, everybody. Finwolf Hard the Stranger. Okay, so I've got what I'm thinking is the necessary parts. Now, what I want is, let's see, not the model, the predictor. And the predictor.model, predictor.model, we run this through. We need to define the model better, though. This is, we have a broken graph right now. So I need to do a normalization. Where's this at? So this is the neural net. This isn't the model itself. So we need to define the model. Ashutosh. Oh, Ashutosh. All right, there we go. Ashutosh, or Ashutosh. All right, one of those. All right, we're at least closer. Name pronunciation. Thank you, Karmu. Thank you. Okay, Ashutosh. All right, so I want to go further than this. Let's see. We want to do a full neural network. All right, let's do this. Okay, we're gonna find it here. Here we go. Class. We'll call this the NN predictor, which is going to be NN.module. So we want to do full module, and we want def underscore init. See, okay, I'm an adult. I like that response. I like that response. This is a good response. Do we have to? Yeah. Okay. All right. So we're going to call it this. And then we want this to be over here. We're going to put this here. This will be the net. The innet. Or we'll call it the innet. I also need to, okay, we've already got that. All right. We got that. Good. Okay. So self dot, I think we just call this mod. We'll just call it module. Although that is the net. That is not what I'm thinking. That's not what I want. We need, let's see here. Actually, it's fine because we're not going to access this. We're not going to access this directly. We're not going to access that directly. So what we're going to do is, where's this at? I want this here, predictor. No, I want the predictor. Where's that at? All right, and this will be a, let's see, we want this module equals, and it's going to be this thing here. Okay, perfect. Okay, excellent. All right, and in fact, since we could just do this. We don't even have to do it. We could just do it like that. There we go. Perfect. Nice and clean. All right, so looking good. Tab A slot B, wedding ring. It's not rocket science. Okay, so we've got our neural network predicted for user input, XY coordinates. What we need to do next is we need to encode and decode the data. That piece needs to happen inside the forward method. Where is that? We haven't defined it yet. We have not even defined the forward method yet. Okay. So def forward self. Okay. And let me say output equals self.model. Excellent. Model. We need the cursor. We need the cursor data. How are we going to do this? Positions, something like that. I think that works. Okay. So we need to capture the positions, and it needs to be, I think, okay, we need to be able to support batching on this with the forward, I believe. So we won't do anything special from that perspective. Okay. Let's see. Ashutosh, good night. Thank you for stopping in. Good to have you here. Okay, so let's see here. Where do I want to go next? We've got our return output, of course. So we got to save that. What else do I want? I need to do the encoding. So if I want to do the encoding for sure needs to happen. Okay, so we need to do the encoding for sure. We also need a train. Do we want to do a train here? We could do a train right here, although I'm not sure. Let's see here. Okay, let's keep going. All right. Looking good. All right, where do we want to go from here? I want def. Myself is wanting this train function because it's going to make it nicer. In which case we should be able to just run the optimizer, I think, right? So let's see here. One moment. We are missing something here. Let's see. This is what we're missing. This is, I believe, in the wrong. I think this is just wrong. I think I want to do this differently. I think I want it to be like this. And then we will grab this data and throw this up here because we're doing it differently now. So here we go. We are going to do it differently. So this. Let's go self dot. Okay, this is better. All right. We're making weight. We're making progress. Progress is being made. So last 3 positions, that's why it's 6. That's the initialization. So this is the model. And then we could do a forward here. Train, self, features, labels, like that. And then the forward just only wants the features. Features. Let's keep that like that. Keep things simple and clean so we understand what's going on there. He's a pro software predicting AI for fun. That's it. Yeah, we are. Thank you, Kyle, for mentioning. Hey, Quantified Quantum, welcome on. Hey, good to see you. We're doing the thing that you asked about. So we've got your base application here, and we already got started. We're working our way. We're making our way now. We're doing it. Bros today's celebrity. Oh, hey, thank you. All right. Let's see here. 1 second. I have a question. Okay, you've got a question. You know RAG LangChain, okay, and LangGraph and N8N. Okay, so a bunch of AI workflow, just workflow tools in general. You could bring AI, usually you do. Generate the codes through AI and then edit it myself for the work. Can I get a job by this technique? Yes, you're essentially the modern workflow engineer. This is going to be sort of a new title. It doesn't exist yet really officially. You'll have a title of AI workflow engineer, something like that. AI automation engineer. What you'll be able to do is take data inputs from some sort of business system, run it through a series of nodes, probably N8N, maybe LangGraph, something like that. Create agents to make decisions for you that a human normally would make. And that goes in part of the pipeline. And the output might store data somewhere as data entry or have a human in the loop. And you create these interfaces. It runs through your chain, and then you productionize it, and you're good to go. It's a whole new skill set. It's kind of, so there have been, data pipeline engineers in the past. Now there's more AI automation pipelines. So it's just like an evolution of that, I think. So yes, you've got it. You got it. N8N is good. It just feels so cheesy doing it and competing in that space. Is it really, Kyle? Yeah. It's a bunch of GUI work for the most part. I do believe you could, store it and save. What kind of job should I apply to? They don't exist as much yet, so it's kind of hard to find them because no one's labeled this title of a job position or this role in a easy to find fashion. So automation engineer, perhaps, though that could mean a lot of different things. That could usually mean like a QA pipeline engineer. So that might not be what you want. Agentic AI. Yeah, exactly. That could be it. See, there's another title right there. That could be a keyword. So what you need to do now, it's going to be hard. You have to find all the acronyms or synonyms that go along with this kind of job or this kind of position. Do a wide fuzzy search and pare down all the postings that exist and then apply to every single one of them. And you're good to go. So that's one of the challenges. We don't know what it is yet. Let's see this. All right. So optimizer loss model. Good. Can we transform? Okay. So I want a transformer here. I want to be able to define a transformer that normalizes the coordinate inputs because they're going to be very big numbers, right? So they need to be a number between like +1 and -1, around that range. Currently, the numbers are large. They're very large. Look here. So you can see here on the screen. So let's take a look here. Control V. There you go. So you can see here on the screen, right here, these numbers are very large, too big to go into the AI. So we need to normalize them. We need to essentially divide by the width of the window and the height of the window based on the XY coordinate. What you see is what you get. Kyle, yep, WYSIWYG. And it reminds you of WYSIWYG editors. Yeah, that's right. Remember Dreamweaver? There was like front page. I'm like dating myself now. These are early days like web editors that allowed you to visually edit offline, right? And now you've got things like Squarespace and Wix. They allow you to build your website directly on another website. Makes it really easy. Oh, Allah, you're building a cost control, FinOps, which enforces cost control and data protection for generative AI large language models. And you want to build a SaaS on it as a startup. That sounds like a great idea. Go for it. Make it happen. I'll help you build your SaaS for 30% profit share. Yeah. Framer. That's a great idea. How's it going? Bill 8L, film, Framer. What do you mean by Framer? All right, 1 second here. Oh, so import QR code, HTML URL, input a bunch of stuff. Wait, save QR code, create it successfully, makes a QR code for any link. Does it really? That is pretty neat. That is nice. All right, QR code second. HTML URL. Nice. This is a Python package. It looks like a Python package. Very nice. Okay, so we've got these coordinates. We need to normalize them. So I want to do this the unbroken graph approach. In Pytorch, there is a way to do this manually in Python that I've been doing because this is just how I've been used to it. In Pytorch, they want you to do it using all of their tools. If you do it that way, you'll have an unbroken graph, which can be optimized for performance and export. That's what we want. So this won't work right here. So we need to get the features encoded. We need to encode the features. That's what we want to do. And then for the output, my challenge is decoding. Can we do this? Yes. Okay. So we need to encode and decode right here. So we need encode, encoded equals something, and then decoded equals something on the output. Here we go. Output something. Okay. So we need to do these steps here. We need to do our encoding. We have to do it using Pytorch primitives. Steven, your channel is truly underrated. Oh, thank you. You teach stuff no one is talking about yet. The followers and likes aren't as that much as they should be. I don't understand. Well, we're just getting started. So, it takes years. It takes years, you guys. So we're making our way. And we will be doing all information is free forever. I won't charge you for learning anything. I think I already know where to begin or start my journey, but still, let's get some pro advice. To get started and start my journey towards programming and other stuff, where should I start? Oh, well, it depends on where you are now. You've had coding experience? Even if you had or not, Python is a really great place to start or continue your journey. Python is used everywhere. AI, data science, servers, APIs. It's really easy. It's clean. All the large language models that are code generators are very good at Python, better than any other language. So if you want to get a low cost, easy to use, and a very powerful and widely industry used language, Python, there's no better. The other one is JavaScript. Get into JavaScript. I think that's another good place to go. That's what it is. I think that's a good one. When I'm working on my project as a side, I sometimes pull up your lives and videos and start building Pytorch deep learning from scratch in Rust. Nice. That's awesome. Incredible stuff. Far better than useless courses. Hey, there we go. Let's do we're coding together. This is what we're doing. We're coding together. Nice. Thank you for your kind words. SAQ 3000 to Kyle. I don't know Python, but don't know about don't know about Pytorch. Okay, so Pytorch is the most prevalent AI framework. I believe every AI company out there uses Pytorch. There's another one called TensorFlow by Google. Pytorch is from Facebook Meta. They're competing frameworks. They both do pretty much exactly the same thing. I think TensorFlow and Keras are easier to use. You can do that in Python. Pytorch is just more standard in the industry. So it's good to try them both. I think it's good to try them both. Okay. Let's see here. Let's get back into it. All right, so we need to encode our features through a transformer model normalization. So I want, so let's see how we do this. All right, so Pytorch, we're gonna read the docs. Pytorch, transform, normalize. That's what we want to do. We want to transform, normalize. Okay. Does it have to be for regular data? Transformer.compose. Okay. All right. So let's do this. Let's try it. We'll try it. Transforms. We're going to need to transform the data because it's going to be XY coordinates. And so we want no data loader. Okay. So, okay. We need to print this stuff out so I understand what it looks like. Okay, so here's our trend. I'm gonna type this so I learn this better. Let's type this so I learn this better. Model. Okay. Whoa. Hold on a second. Let's load that there. Okay. Let's hide that for now. Okay, looking good. All right, we don't need that on the screen anymore. Let's bring that up so it's nice and pretty. You wish there was more diffusion-based AI coders out there. Diffusion-based. All right, so we could do that too. Diffusion's not that challenging. There's, because it's all about turning noise into something. Usually a picture or video. Usually a picture or video. And it does take a lot of compute, right? It takes a lot more compute. So you're right. I mean, the reason why it's not widely out there is you do need good hardware to do that because it's a pretty compute intensive task. All right, so let's see here. What was I doing here? All right, so let's type this in. Okay, so we want our transform. Let's do this here. Okay, self.transform equals the transforms. Hold on a second. Transforms that we imported dot compose. Okay, and this will be our pipeline here. So we don't want a broken graph, right? So we want a transforms dot it's like a dot to tensor, okay? And then we also want transforms dot normalize, and it wants us to see how to normalize them. Since we're doing XY, the input is going to be 3. So we need to say like 0.5 a bunch of times. Like that? Is that right? We need to say it 6 times. 1, 2, 3, 4, 5, 6. Like this. And then, okay, so let's do, how do we want to say this? Distribution or how would we just say dist equals? No, not that one. Whoop. Got to click the right buttons there. Dist, comma, dist. Like that. Okay. Comma, make it pretty. Looks good. Okay. Perfect. Okay. All right. any of its particular advantage. Wait, what are you talking about? Oh, subject of AI. How's it going? Good to see you. Curious what your preferred IDE is for coding. I use Vim. I love Vim. So you see here, let's see here. Vim. You see we're running Vim version 9.1, 754. It's a good version of Vim. It's regular Vim. It's not Neo Vim. It's just regular Vim. It's just standard good regular Vim. From my experience, I have some experience doing Python, but yeah, I haven't used it in a long time. All right. Python's great. I like Python. It is the premier AI language. It's the premier AI language. Nahariak, thank you. Thank you for your subscription. All right. Welcome on in. This is the coding channel. We do software engineering here. Gotta go by. Eddie Legendary, it's good to see you. Thank you for stopping in. Have a good Friday. Close that. Close this. Okay. Get rid of that. Okay. We do coding on this channel. AI, Python, Rust, C, assembly language. We're doing it all. We're doing it all. Python, though, we'll be mostly doing Python and AI for the most part in the foreseeable future. Is what we're doing. Okay. Let's see. All right. So we've got our distribution. I think that's what it looks like. I think. Although we're going to test it out. We're going to test it out. I'm not sure if this is what I really want. We'll try it. Okay. So let's see if it'll run train pass. Let's see if we have anything broken here. All right. 125, 125. Okay. So predictor. That's right. There we go. So we got our predictor here. We got our gain. Frames per second. Might as well bring this up here at the top. Marker. All right. Got our marker. Wait. Marker. Point marker. This could go up here. Keep things going. All right. Okay. All right. Making it good. Now we've got our predictions, which is going to have the AI predict where the player's movements or the next click is going to be. Okay, predictor, and that gets passed in there. So that way we can do the analysis on the data with reinforcement learning and then do the predictions for every click. Well, actually, let's see here. I need to think about that for one moment. I need to think about that because we might overfit if we can. We want only when there's new data. Okay, so that's something else that we have to do. Only train and predict when there's new data. When there's essentially a click occurs. When a click occurs. Okay. Which we could run in here. Right, so to do only run when a click occurs. And we can do that pretty easily by detecting and storing state in our object to see if the length of the pointers are, or if there just was a number of clicks. We can just track the number of clicks and see if we are on track with the number of clicks, or something like that. I think we could do that. We could do something simple like that. Track the number of clicks. Okay, so self dot click 0. Okay. So we need to increment this every time there's more clicks. We can do that here. Okay. So how do we want to do this? So one of the, you know what? I'm thinking, hey, Steven, how's it going, Abby? How are you doing? We're doing good. For reverse engineering on Android apps, straight into it, are we? What AI model or platform works faster or smarter? I'm using GPT-5 on Cursor. It seems like it's not smart enough. Reverse engineering. So are you looking to reverse engineer an existing, like, decompiler? Do you have a binary or an existing app that you want to deconstruct? Is that what you're doing? So you'd want to run a debugger, probably. You're running on a Mac, you said? or Windows. So you'd want to use GDB or LLDB to decompile the assembly, and that will be your first step. That's like one of the steps that you could do. POV chat room, bruh. That's one of the steps you can do, Abby. That's one of the steps. So yes, try to find ways to. However, if you have the source code, you don't really need to reverse engineering anything. So that's what I'm thinking. You're probably trying to reverse engineer a binary. Otherwise, you already have the code, and there's nothing to reverse engineer. Okay, let's see here. All right, so predictor, clicks. Do we need? Wait, hold on. Wait 1 second. We don't need. We can delete something up here. We don't need this anymore. We don't need that. That's gone? Okay. This is redundant code. We no longer need that. Okay. So predictions, predictor class. This I'm not sure about. We'll figure that out later though. It's probably fine. It's probably unnecessary is what I'm thinking. You're reverse engineering an Android APK files. It's already built. Okay, so an APK, I believe, has the binary. Well, is it a JVM? It's Java bytecode? Is the APA Java bytecode? It's not all right. It's like a zip file basically. So you need to extract all the files in the APK, which will include images and other assets. Hey, Baggish, how's it going? Hello, brother. Good to see you. Happy to have you here. Happy Friday. We're doing AI today. We're building an AI future prediction model. Okay, let's see. So wait, how do you do that? Extract APK files. All right, how to extract an APK. So you want to do that. You need an extract an APK. How do you do this? APK extraction or unzip basically. An APK file is basically a zip file. Rename it and extract it. Oh, what? Is it really? Isn't APK a zip file? Is APK a zip file? So then you just rename it to .zip and then you say unzip. Yes, APK is fundamentally a zip archive containing compressed app components like the code, resources, manifest, right? So yeah, so I told you. So you get a manifest XML file, you get all the images. So you just rename. Okay, so here you go. Yes, it's a zip file. Hey, we're figuring this out, aren't we? So yeah, you just extract it. You're good to go. Now you're one step closer to your disassembler. You will have, what is in here? What's in it? Libraries, asset, manifest XML file. Yep, there you go. So you extract it, and then you would want to go into the compiled app code. So there's a classes.dex file, it looks like. So you want to decompile the classes.dex file. And that's your next thing. That's what you do next. And it would be yes, brother. Oh wait, would you help me choose choose a career path? Sure. Baggish, what are you interested in? What do you want to do? Probably AI something, right? That's the future. That is the future. AI something AI. That's what we're doing right now. We're doing some AI. Okay, so what do you want to do? That's do the thing that you want to do. That's what you should do. Otherwise, you're gonna live your life not liking it as much. You want to watch Dexter movie? Wait, there's a Dexter TV show, right? Dexter, which is a serial killer that kills serial killers, right? That's a great show. It's a great show. I love that show. I stopped watching after season 4 though, because it got weird. Season 4 was the best. Nice. It's Shivansh. Wait, what do you mean Shivansh? Okay. You're into Java and DevOps. Oh, nice. DevOps is a great career. So you'd want to study Kubernetes, orchestration systems, databases, database management, service discoveries, routers, network layer stuff. Then there you go. There you go, Shivansh. There you go. That's the show. You got some Mr. Robot stuff in there. Those are great shows. Yeah, Mr. Robot, Dexter. What else is really good? If you haven't watched Pluribus, that's also a really good one. It's great. I'm enjoying that show. It's a good one. What I want to know is what AI model is good for complex tasks? Claude, Gemini, Codex. Well, Codex with GPT is mostly for coding. I think Claude is pretty good if you do Claude on the command line. So do Claude command line, and you're going to get a lot better results. You have a file with a ton of directories and decompile the APK file, and it's heavily obfuscated. So AI must be quite smart for it. Oh, well, Gemini or Claude will give you the best likelihood. Though, if you're going to try to get AI to make sense of it for you, I don't think they're trained for that. They're not built. They're not built for that. So it's too risky. Suffering from many layoffs because they're not hiring and can switch again and again. It's tough. It's tough. You got to try something though. If you try nothing, you immediately fail. You tried Codex, it didn't work as expected. All right, try Claude CLI. That's the best, or Gemini CLI. Gemini is supposed to be better than all the others right now. It's apparently number one. Dude, Gemini CLI, that might be a good one, a good option. Okay. Things like Gemini Flash 3 is supposed to be the best state-of-the-art model available today. Other than, I think, GPT 5.2 Codex also just launched like a day or so ago, and that one's supposed to be the best by only a few points, though. It's up to you. I mean, you got to try all of them. I don't know, though, if it's going to work with decompiled code, especially from the obfuscation. Obfuscation. I'm a master's student last year, and I'm applying for right now for my course. It's going to end in 6 months, and the hiring process is not good right now. It's a challenge. Yeah, I'll think this out. Thanks for your help. Sure, happy to help. Nice. Okay, let's keep going here. Let's get back into this. Where did we end up? Okay, so we've got number of clicks. Clicks is 0. And then we need to, let's see here. Lin points, right? Let's see your Lin points. What's your LinkedIn profile? Let's see here. It's around here. So let's see here. 1 second. I got it. LinkedIn Steven. Here you go. It's on our Discord channel if you're interested. But here you go. Here we go. Right here. Yep, looking good. Okay. Bro, what a coincidence. Is this what is studying in theory? You are implementing that stuff? Kareem? Hey, I know. Isn't that neat? All right. That is a coincidence. Yeah, here you go. Here's LinkedIn profile. It looks like this. It's also on our Discord. I'll paste it again on Discord under our Discord resources links. Here you go. There you go. Paste it on Discord. There you go. Yep, you'll see here. That's the profile. Okay. Actually, you know what? We can keep that around because that is that is often referred to. Okay. 0, go back over here to the code. Points equals, where do we want to do this? Let's do this over here. Let's see here. Clicks. Self.clicks. Yes. So we got to do this one first. This one's going to be first. Okay. Points. It's going to be exactly the same as if return. Because we only want to do this on a click. We'll only do this on a click. Bro. Please, my bro. What are you asking? Should I send you a connection? Sure, let's do it. Send the connection away. Would be happy to click the button. Let's see here. Points marker. Let me know when you do that. And I can do it. Okay, so if clicks. Right. This. Okay, yeah, perfect. Okay, yep, that looks good. Okay, so we want to only run AI when user clicks. Okay. And then only allow AI to run if we have enough data samples. That's what that is. That's what this is about. Okay. All right, we did the to-do. We need the clicks to be, we need to increment the clicks. Okay. Also, it's going to not be self. It's going to be predictor here. We also probably need the game object for later use to draw on the screen. That's what we need there. Let's see. Steven, what's tour fixation? I don't know. What do you mean by that? Did that, bro? Okay, I would definitely reach out to you for any help in case I switch to AI. Nice. Yeah, that's the way to go. Merry Christmas, Justin. Merry Christmas. Happy holidays. That's right. It's the exact time to say that. I hope you would guide me in that best. All right, sounds good. Hey, Varunsani, how's it going? Hey, Steven, good to see you. Happy to have you here. Okay, what's your mini keyboard? What's your mini keyboard? What? No mini keyboard. I don't know what that is. I don't know what that is. Okay, so we got her this. Predictions. Okay, game looks good. Points. Yep. Clicks looks good. Points. All right, so this right here is points right here. Okay, so that works good. That works well. What we need to do is in predictor. Let's see. Hold on. Clicks. Points. Let's do this. I think this is better. Okay, this will be clicks. Clicks. And then we go like this, and then we go like this because we're doing this a lot. We're optimizing a smidge here. Predictor clicks. CLI clicks. Thank you equals points. Okay. Set click number of clicks so we don't run next frame again. Okay. Looks good. We're doing good. We're doing good. Happy New Year 2026. Yeah, it's coming up here, isn't it? It's coming up. Would you please do it live? Yeah, let's do it. All right. Let me go into LinkedIn. Let me hide some things so I don't show other things happening. One moment. One moment. All right. So network. All right. We got to make sure you get the right person, though. It's loading. It's taking a while. Okay. Where is this? Where is this at? Notifications. No. Network. I thought it was a network. We're looking at. I'm pulling it up here. Invitations. All right. All right. I see ya. I see you. I see you. Okay. Here we go. All right. Here you go. Right here. Shivanj. Right. That's you. Accept. Okay. We got you. We got you. Oh wait. You can't see. All right. So, hello. Okay. I sent you a message. I sent you the message. Here you go. You can see there. We got you. All right. Let me bring that back over here. Let's go back. Okay. Perfect. Okay. 0. Bring this back over here. All right. You don't like your keyboard, SAQ3000? It's Shivansh. All right. Yeah, I figured it was your YouTube name and your LinkedIn name match pretty well, so it was pretty easy. It was pretty easy to find you. Okay. Let's see here. Where are we left? What time is it? Okay. We can keep going for a little while longer. I would like to be able to get a full feed forward going. We could get some of the training going, though I don't know. We're really close. Like, we're really close to being done on this. We're very close. Okay. Let me make sure that this runs. Okay, so clicks. I want to print this out. Print F clicks equals points. Nah, it doesn't really. I don't know. You know what? Instead of calling it points, well, let's call it number of clicks. Number clicks. Do we want to do it like that? Number clicks? Is that why I want it? Is that why I want to do it? Yeah, I think so. I think we could do it that way. Okay, let's do it that way. Number of clicks. Number of clicks. There we go. Number of clicks. Excellent. Excellent. Okay. Perfect. And this will be clicks. I'm going to change that. Okay. Looking good. Let's run this program and see if we crashed it. Okay. Got it. All right. I know what to do. I know what the problem is. 97, GG. Okay. Right here. It's because we haven't defined the model yet. So we could fix that by just moving things around. Look at that. If you are a recruiter, sometimes, currently we do have an open AI role. It's for senior engineer. So that is available. All right, let's see if that works. Wait, I thought, oh, did I not save it? No, wait, what? Why is it? Oh, wait, did I type it wrong? Oh, it's self off. Got it. I did. Okay, so we can fix that right here. Boom. All right, next one. Okay, so a bunch of no clicks. Click, 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 click. Okay. Weird. Wait. Oh. Okay, we need to save this data then. Because it's not what I want. Okay. I'm glad we tested that. That would have been very confusing. Okay, so we need to save the we just need to do this. Let's see here. Predictor.clicks. Okay. One moment, please. Marker points. You want to review it on your YouTube live so that I can get to know what to keep. Wait. Review what? Wait, review on your YouTube live so that I can get to know what to keep and what to remove. What do you want to review? The profile? Are you talking about the profile? Let's see here. Let me know if that's right. Let me know what you were talking about, what to review. Let's see here. We're making a lot of changes and also not fully focused on this right now. Okay, so this looks good. I'm happy with that. We've got the normalization, distribution. Spell that correctly. Yes. Okay. I want distribution. Looks good. Looks like that. Okay. Transform. We've got our model. We've got a loss. Let's go up here. Bring this down there just to make it a little bit easier to read. Just a little bit easier. Yeah, I want to review the LinkedIn profile. Okay. Let's go. One moment. Let me take that. Let me hide that for a moment. Okay. Go to this. All right, we got your profile. Okay, let's take a look here. I always scroll straight down to previous job experience. You don't have any. Pass. That's it. Where's your job experience? I know, it's like the first thing that everyone goes to look for. So since you don't have any job, you really don't know internships or anything? Volunteer. You need to get some internships. Or something, right? Something so that way you can compete with the rest of the industry. There's nothing there. You told you were a fresher? Yeah, so you got to get some internships. You got to do some real work. So try to get some internships, or that's what I did too. Even I had to do that, and the market was still kind of okay. So now especially you need to do that. Or, see if you could join a startup or build an app and release the app and get users. So you've got some paths here. Maybe you should do all of them. Internship, entry-level positions, build an app, release it, get users. Join a startup. You've got some options. There you go. That's what you got to do. Otherwise, a recruiter is just going to pass on you. Or what you could do is, if you're talking with a recruiter and say you want just foot in the door jobs, that could also work because you don't currently have any. You don't have any. Let's see here. You don't have anything. You don't got anything. You got some projects? All right, projects are okay, but you need to release them and get users. Do you have that? Student deeds. Let's see here. Is this the right? No, that's not it. That can't be it. Is that it? Oh, here we go. Okay. So yeah, this is just, let's see, Java, DevOps Bootcamp. So this shows that you've got the skills. It just doesn't show that you've implemented them in the industry yet. And that's like, you need to apply in the industry. What is deploy me? Okay. Oh, hey, all right. So this is a good step. So you've got a Netlify app here. All right. Looks good. Okay. So it seems like, did you handwrite all of this? Hey, look at that. Look at that. Hey, right there. Right there at the bottom of the screen. Look at that. Made with Shivansh Baga. Shivansh Baga. All right, nice. Very nice. Okay. All right, so let me close some of those. So you're off to a good start. You just need to get some experience now. I think that's the next thing. That's the next thing. And you already know that. I'm not telling you anything new. Steven, question. Do you think it's possible to make from Mobius strip to normal strip and back to Mobius strip? Time travel stuff? Well, I don't know about time travel. I also, Mobius strip is just, and you just take a normal line and then you right? A normal strip of paper and then you twist it and then connect it. It's Gen AI somehow. Is it? So then it actually wasn't you. Wait, did you Gen AI that? I mean, it's the way the world's going. I understand that. Though it doesn't necessarily show that you've got the ability to work with the AI to be as skilled as the AI. Mix of my skills and Gen AI? Got it. Okay. It's so weird. The world is just so different now. Everyone's using Gen AI and it is the way to go. It's the industry standard. Everyone expects you to use it. I use it every day. We're not using it now on stream because I don't want to sort of atrophy. So there's zero AI going on here. I am looking up docs and things like that. So there's some help there. I'm typing everything myself though. This is all by hand. All right. So we do have to get going here pretty soon. So I'd like to make enough progress where we get our encoder working. We need to get our encoder working. And the decoder, I don't care about right now, but that's not like it's a hard thing to do. And so this is the normalization, which is the encoder phase. So we need to run the transform before we run it through the model. Or, let's see, I need to figure out how to use this. This is something I haven't used before. So I've got the docs open up here, the transforms. Let's look at the docs. Let's read through the docs here really quick. Transforms, okay. So that's not helpful. Target transform, scatter, torch tensor. See, this was not helpful. I need to see how to use this. Let's see here. All right, this might be better. v2.compose. What is v2? Import v2. Weird. So wait, very interesting. Okay. Very interesting. But recently I have stopped using Gen AI and just focus on your Java skills. Nice. And data structures and algorithms to form scratch and crack a job. That's a good start. You're on your right way. You're on the right way. Should I be using v2? v2.compose. Interesting. Let's try that. Let's do v2. Is that right? Are we doing that right? Got it. Transforms v2. All right, from v2. Okay, transforms. I think we just say v2. Is that what we do? v2. I'm not sure. Okay. v2. Yep. Okay, good. We're in the right spot. Okay. We're good to go. Looks good. Bro, can you please teach me how to make a game character controller? Hey, Chatteruk, I don't know. What do you mean a game character controller? What is that? Are you talking like a VTuber type thing? would ping you for sure when I crack first job. Nice. And say thank you. That sounds great. Good luck. You'll do great. You'll do great. Thanks for taking your time and reviewing the profile. Lots of love. You're welcome. Happy to help. I know it's pretty standard recommendations, from this, but it's real. It's real recommendations. Okay. So I want to, so transform. Okay. Got it. Okay. So we need to run this over the data. So we just run this as a function. So the forward will be like this. The forward's like this. Features. And this is the features equals features. Okay, so print before after. Nice. All right, so this is the encoding step. All right, there's our encoder. That probably will work. I don't know. I'm pretty sure. We'll find out. No means a lot to you because no guidance. So genuinely, thank you. All right, you're welcome. Yeah, I'm so happy to help you. Let me know if there's any other questions you might have. You can check out your other projects as well, though. Sure, let me know. Put it in Discord. Put the links in Discord. Any other projects? Send them in Discord. Let's see here. All right, let's keep going. All right, so we've got our transform encoder. We should probably we could call this encoder, right? Encoder. Just to make things a little more obvious what's going on there. Features. Okay. What does that look like? Also, we can't trigger forward yet because we've never done it. We've never triggered a forward before. Okay, so output equals predictor dot forward features. Okay. Looks good. I'm pretty sure that's it. Sure, man. Thanks a lot. Excellent. Sounds good. Okay. So we need the predictor to also capture the clicks. Unfortunately, there is a problem with the point list. It is not stateful. Well, it is stateful. It's temporary. And I need permanence. Like a Unity game in C#. All right. Yeah, C#'s great. I love C#. Character controller script. Yeah, I don't know. So I'm also a newbie when it comes to Unity. We've only done a little bit of Unity on stream before. I get the game objects. I get the state of the objects. I understand, the render loop, a few other things. I've got a game going, though. I guess the only controller part that I have is the mouse cursor, the mouse pointer, right? The mouse cursor here. And that's all I got. Are we building a vector DB for retrieval augmented generation? Hey, Code Linkson, good to see ya. Right now we're building a point predictor. The user clicks on the screen and the AI is going to predict where the user clicks next, which we're probably going to have to continue on Monday because we're basically out of time right now. We're out of time. We're like overtime right now. Let's see if we can keep going though for a little bit. I would really like to be able to get the clicks to run through the model and encode and get an output. Before that'll work, the point list here is not permanent. It is temporary. It gets removed. So what we could do, 1 second. We don't want to render all the circles. So I need a separate point list. I need a separate, where we do the pushing, I need to push as well. So right here, okay. So we need a separate list. Point list self.ai point list. Append. We just do the same thing here. There we go. Very cool. But I built my first chatbot from scratch using TypeScript. Hey, nice. TypeScript's a great language. Obviously, it's a, superset language on JavaScript. That's not really its own language. It is a high-level sort of scripting language that gets transpiled into actual JavaScript. It's pretty good, though. A lot of people use it. It's pretty great. Okay, so we want this. We want AI underscore. Great. Okay. So we'll use this. And whenever we push into it, where do we push? We also want, we did that. All right. So we're appending here. And then instead of using point list, we'll use AI point list. Perfect. Now, I think we're good to go. We probably missed a few things. Yes, it's stricter JavaScript. Yep, you got it. It's stricter JavaScript. It certainly is. Because there's a transpiler that lives on top of it that needs a specific structure mandated in order for it to actually transpile the JavaScript. Aiden Harris, hey, how's it good to see you. Well, come on in. We're almost about ready to run our AI model for its first forward pass. There's no training yet. It doesn't train yet, but we are going to run through the forward pass here. I do believe that is the incorrect way to do that. We have to do it like that. There we go. Forward. Forward. Good. Okay, excellent. Predictor output. And then it will run the forward, encodes it, throws it to the model, and returns the output. We need to decode it, though. This is a to-do item here. To-do. Decode. We gotta decode. We gotta decode it. There we go. Woohoo! Yeah, I know. It's exciting. I'm excited about this. We're very close. Like moments away. We'll run it. We'll see if it works, and we'll get a print on the screen. I need to check some things out. You wrote a chunker. Nice. You need the chunker. Got to split it up for the vectors and the vector DB embedder and all that with a browser UI client. Really? That's actually pretty impressive. Why not use in or make? You could do that too. Conkit, you could actually do that too. That also works. It's a learning experience, the way code Langton's done, to build it yourself without using a major framework. So it's good practice. It's good practice. I do that. I do this all the time. I've been in the industry for many decades actually, maybe 3. I'm very old. I've been doing this for a very long time. I'm super old. So I still build sample projects all the time to keep learning new things. It's a very common practice. All right. Second, look in here. Okay. All right. So, whoa. Here we go. Okay, excellent. Encoder. Okay. Model. Perfect. Yes, this should do it. And the forward function will get executed by the call, the double underscore call method, which looks like this. It's the call, underscore, which is built in to the in module. So all we have to do in order to run this forward is to run the predictor, which is right here. Where do we put that at? Right here. Excellent. Okay. All right. We're going to find out. Is it going to work or are we going to crash? All right. Got our crash here. All right. So, right. Number of clicks. Okay. Let's see here. Number click. Never click. Why is that a problem? Not supported. Oh, it's a list. Right. Okay. Clicks, AI point list. That should be fine. That should be perfectly fine. Predictor AI. Oh, right. Okay. Let's see. That should work perfectly fine. We'll figure this out. Hey, Victory Smart. Hey, Stephen Blunt, what are we doing today? Hey, welcome on in. we are building an AI that predicts the next point where the user clicks on the screen. It's a click predictor. Really simple reinforcement learning type situation. Very simple. Use OpenAI for API for vector embeddings. Nice. In Postgres. Yep. PG vector. Nice. There you go. All running in a Docker container. Excellent. So it's platform agnostic now. Very nice, Code Langtons. That's great. You did it right. You did it right. Any recommendation for someone mainly in the no code space to transition into proper coding? Yeah, use Claude. Just try out all the different code generators. Claude, Gemini. Gemini is the best right now as far as I can see. Although Codex 5.2 Super Pro is the best, though. Gemini I would say is probably the best because it's fast. It's going to be faster for free. It's also free. That's rad. Bloodfire, isn't it? I think it's pretty neat. All right, so here we go. Why that not worky? This should work. So clicks, AI point list. Yep, looks good. It's an ever-growing list. So you see the total number of clicks. As that increments, clicks. Oh, predictor.clicks. What is that? Did we don't need to, this could be a number. This needs to be an integer. Where is that at? Oh, here we go. This is what's going on. Here we go. That should do the trick. Okay. Better now. All right, here we go. Here's the screen. Click. Yeah. Click. Okay. That's a big error. What happened? Oh, we'll figure this out. Looking. Call implemented. Linear argument input position 1 must be a tensor, not a list. I thought we did. Oh, didn't we transform? Maybe we didn't transform it. Let's see. We've got our encoder. How would this predict the next click? How you get... the user will click on the screen. So as you saw there, I was clicking on the screen. That's going to be the input data. And then over time, the AI is going to learn where you've clicked, and it's going to sort of remember your pattern. And it will be able to, not very well. I don't know if it's going to do very well or not. I can't tell you for sure if it's going to do well or not. We should probably do a lambda here. I think we need to do a lambda. To do lambda, we need to do this. This needs to happen because we're not going to get the ability to properly decode it because the encoder is going to give it a different distribution. So it's probably not going to work. What activation function are you using? RelU and tanh. RelU and tanh. So where is that at? Here is in our linear. Here you go. RelU and tanh. There you go. RelU, tanh. Right here is our activation functions. There's our activation functions. Would you like many? Okay. Oh, now you see. Nice. You will ever do this from scratch though without using Torch. We did. We've done this from scratch without using Torch. We actually have a stream. We did this mostly from scratch. We use NumPy. NumPy just helps, make it so you don't have to write your own for loops, which is really nice. So we did this. Yeah, we actually did it from scratch without Pytorch. I claim it's from scratch. I make a claim. How many lines of code have you done in my entire life? Well, today I think we did about 100, right around 100, or not over 100, probably right around 100. In my life, I don't know, a million, around there maybe. I'm not sure. Oh, your watch, nice. All right, so we're really close. We're almost done. So we got to fix this error here, and it's. Oh wait, 1 second. I'll be right back. BRB. Okay, That is a lot of, isn't it? I think it's a lot. You're a great, man. Keep it up. All right. Thank you, Bloodfire. We'll keep it up. So input argument needs to be a tensor in a list. That is fair. And what line is that on? Call stack, call implement, I believe. Okay. So I did 2tensor though, which is annoying, right? 2tensor. We did the encoder. Did we call encoder on it? Features. Yeah, see, we called it right here. Let's comment this out and see if that will prevent the error from occurring, because I think that's exactly where it is. Let's see here. Run it again. All right. Click, 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 click. All right, okay, cool. That was where the error was. All right, so we got a lot of clickety clicks. All right, now let's hide the click print because we don't need that anymore. We will print number of clicks here. Let's try that again to make sure that works. Click, 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 click. Yep. Okay, yeah, that looks good. Clicks 9, 10, 11, 12. Perfect, perfect. Excellent. Before, after. They're identical, aren't they? I do not see any encoding. Also, what am I looking at? What is this? Okay. Okay, I get it. So we need to do something different here on the append. This we need to capture differently. X comma point dot y. Maybe. Can we do that? Will that work? No? Okay. We need okay, we'll figure this out. We need to, where was that at here? Okay, so here is a point and it needs to be, oh, do you have cost function or yes, we do. Derivative, yes, or the error rate, we do. We've got the loss. We have not written a cost function though, because we haven't gotten to the training part yet. Though I'm just going to do a regular sum of losses. Just the sum of losses, the average loss is what I'm going to do for the cost. So simple, keep it simple. Keeping it simple. What am I looking at here? What is this? What is this? What is this? Why is this? Okay. Print point. I need to see what this is. Point. What is that? Okay. Let's find out. We're going to find out here. Okay. You're the best streamer ever? Oh, thank you, Aiden. Thank you for saying that. That's great for you here. I appreciate it. All right, so point. Weird. That's what a point is. Position. What if we go up here? Position. Okay. So point dot position is what I'm looking at. Okay. So I need to capture position. Also, I do believe it's written here. Where is that? Point list. It's also available here. Draw. Where is this at? Where is this at? State. What is state? Timer pose state. Circle. Circle for point in. Okay. So what we need to do is we also have to transform the input and capture the list. But before, we don't even need to do that. We don't even need to do that. So what I want to do is do that up here. Let's do that here. Like this. And then we will only append point or POS, the position like that. Pause. I think that'll do the trick for us. I think that'll do the trick. Strong agree. Nice. Thank you. Thank you, Boltfire. All right. Oh, wait. 1 second. It's not circle. It is, where'd we do that? Here. It is point. Perfect. Better. Okay. Looks good. Point. Yep, that's exactly what I want. That's exactly what I'm looking for. Excellent. Excellent, excellent. All right, so that'll be X and Y. Yep, looks good. And then X, X, X. Yes, yes, yes. All right, we're looking good. We're looking good. All right, point, list, happy, got what I'm looking for. That means that we've got our X and Y. So these are our clicks. And we need to do is we need to flatten it. I think there is a nice, happy flattener. A nice, happy flattener. v2.flatten. Can we do that? Is that possible? Is that something that'll work? Also, this won't do what I want it to do, I'm pretty sure. So we need to fix that as well. Where is this at? Features. Looks good. So these will be the X and Y coordinates of each of the events, and then we'll flatten it. Encoder, print before and after. Perfect. Let me make this a little more obvious. Okay. Perfect. So far, so good. Now I want to make sure. All right, let's run. Wait, was there any other prints? Yeah, that's what I want to do. I want to get rid of all the other prints. Don't care about that. All right. Looks good. Looks good. All right, let's test it. Okay, so we need a flatten transform. It would be nice if we could flatten it straight up, although I don't know if that's something that we can do flat. Can it just not be? Or does it have to be? See, because I need before, what do we want to say here? Before, do we flatten it before or after? Because it's not in the right, I suppose what we could do is we don't need to actually run the flatten. We can just prepare the data ahead of time. So let's see, I suppose 6. So we could do 2 appends, essentially. We could append twice. Suppose 0 for the X, right? Let's do this. X equals pose 0. Y equals pose 1. X, Y. We could do something like that. Also, before we do that, though, I'm wondering if let's just we'll just keep it simple. We won't go advanced or anything beyond that. I think that's fine. So that'll flatten it for us. So we don't need to worry about that. Okay. All right. Before and after looks good. Before, after. Before, weird. Oh, okay, got it. Okay, I know what we're doing now. So this needs to be 4 times 2. So that will be 8. So we need 8 here. 2 and 2. Because the output is going to be 2. Perfect. Okay. So there's our input. This is the output, or the labels. Okay, so that should do the trick for us, I believe. Let's try it again. All right. Click, click, click. Click, 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 click. A whole bunch of clicking. All right. 1, 2, 3, 4, 5, 6. Right, 6, because we're doing a bunch of ones. So let's see if we can get... All right, looks good. Okay. Excellent. All right, that's what I'm looking for. Now we need to transform it. Right? This normalization did nothing. It did nothing. It didn't do anything. So how do we do a v2 lambda? All right, let's look this up. v2 compose transform lambda. How's it going? Lovek, how's it going? Okay, I saw your message there. I saw your message. Let's see, lambda. Perfect. This is what we want. v2.lambda. Excellent. This is what we need. v2.lambda. That doesn't do anything. All right, lambda. Okay, we need... This is going to be tough. Okay. I want to put everything there. I want to put everything... Okay, I suppose we could do x, y. Can we do that? I don't know if we can do that or not. I really don't know if we could do that. Divided by... Where is it? Width. Window. Game. Game... We have the game object, so it would be great if we could capture the width and height, which is right here. All right, so let's do this. Pygame. Let's copy and paste this really quick. Copy. Window width and height after. Okay, let's see. I want to grab the game width and the height after it's initialized. So, okay. Okay. Easy docs. Okay, perfect. Okay. Where are we at? I wanted to say hi quickly. Okay, Kit Kat Life, good to see you. Thank you for saying hi very quickly. Thank you. We're almost at the point where we do have to get going here in a bit. My hamster just did a backflip. Did it? All right. That is a very skilled hamster. Hamsters don't usually do that, I'm pretty sure. Unless they're like in a wheel, like a running wheel, and they did an unintentional backflip. But if that could have happened. You could use the screen width. Oh yeah, I would like that. The jam, I want to do that. The screen width. That's exactly what I would like to do. The screen width. That would be great. Blitting? Got it. If you're blitting to a screen, maybe cleaner just dropped in. The jam, great to have you dropping in. Good to have you here. I'm just looking. So I do have what the docs tell me here. Here's the width and height to get the surface of the display, which is basically the screen width and height. So we've got that. So we can use that. That works great, which should be the reference to this right here on, should be the reference. Hope she's okay. She fell higher level. The cage has 2 levels. That sounds harmful. That sounds danger zone. You got to be careful there. Oh, wait. Game window width height. Oh, it's right there. It's right here. That's a lot easier to deal with. Let's grab that instead. Let's grab that. Okay. Where is my lambda at? Okay. We have our game. Wait, or do we? Oh, no, we don't. Okay. So we also need to set the width and height here. This is not good. Because I need to think about this for a second. Rick, if I use replicate code, can I edit the code app in VS Code? Yeah, absolutely. You absolutely can. She's okay. All right, Kit Kat Life. That's great to hear. She's okay, you guys. The hamster is okay. The problem is... Okay. I've got an idea. We're going to have... Well... On initialization, we could also just pass in the game. So we'll do predictor, and then we'll do game. Actually, here we go. Like this. We'll do game. And then it wants the game. And then now we can do it. Now we can do this. Width. See, I don't know if this will work. Okay, so width and comma, y, game height. Like that. Okay. So here's the thing. I don't know if a lambda could work like that. I don't know if this will work. I don't know if we could do multiple lambdas like this. We're going to try it. We're going to try it and see if that works. See if our encoder works properly. Okay, so we don't need distribution anymore. Optimizer loss looks good. Okay. Let's run it. Is it going to work? It's defined right here. Why is it not like that? Does it need that? Huh. I coded my replit using Python. How do I set up Python in VS Code? You just open the file. You just take your file, you point VS Code to whatever folder you want, and then you just open it right up. There's no setup, I believe, unless you're doing a virtual environment. Then you need to activate. So in a virtual environment, you need to run source vn bin activate. So you might need to do that. That's the only thing you got to do. You might have to do that as well. 1 second here. See if I can get some help on this. Because how do you do a lambda? Python lambda multiple, no, not multiple lines, multiple parameters. Parameters. I'm doing, that's exactly what I'm doing. I'm doing it the right way. That should be fine. Python lambda return multiple. All right, are we returning it the right way? X, Y, X, so that returns 1. We have to return it as a tuple. I don't know if that's going to work or not, though. Well. Oh, we typed something. All right, line 48. 48 GG. Wait. Or if you're on Windows, it's venth script activate. Oh, the jam. Thank you. I didn't know that. I didn't know. I thought they were all the same. I didn't know. I'm a Unix person over here, so. It should have never gotten to this state. Thanks. I also have how I test it. That's also how you test it? Nice. Nice, Rick. That's awesome. It's because the game window isn't getting created when it's being called. Oh, it might be. It could be game window stuff. That's a good point. Well, this seems to not crash anymore. So that part's okay. We got a new error now. Which is right here. I do gotta get going. This is like the one thing I want to do, a full unbroken graph on Pytorch. Okay, so it is. Oh, so it doesn't look like it wants me to do more than one output per time. So what if the X or the chord, what if we did it different? What if we did it like this? What if we did chords? Chord. Do chord 0 and chords 1. And then we need to do flatten. Do flatten. We have to flatten it. We got to flatten it. Pretty sure. If we can. Okay. Tensor. Well, darn it. So that's the problem. All right, I'm seeing a problem because I need to understand the current position. Man, every time I catch you, it's for 5 minutes. Dang, this bell, it doesn't work half the time. Oh yeah, I know, right? The notification doesn't always shoot out. I see what the problem is. I'm not sure how I want to approach the solution. Let me look at the docs. Let me read the docs here. My app is using Payment Gateway API. Can that work in testing? There usually is like a test credit card number, like 000 or all fours. So that works something. What's the problem? So we've got all of our coordinates, and I need to normalize it as the input. I need to encode it. So that's what we're doing right now. We're just working on encoding. Obviously, I can pre-encode it manually myself. I am doing something that I want to try to learn, is creating a fully unbroken graph. So it's raw input data, unchanged input data, just XY coordinates of the mouse where it was clicked. The XY coordinates of the click. And we're storing that into a list of clicks. And that will be the input data or the features for the model. We need to convert that list into a tensor, and we need to convert the raw coordinates into a number between -1 and +1, or like just maybe, a small number that the AI can understand when it's doing its feed forward. Otherwise, the numbers are too big and it can't learn, and it will cause, the inability to activate properly all of the parameters or the neurons, right? It won't activate properly. So we need to normalize the data or encode it. We need to encode the data. And I need to find a way to do that. That's what we're currently doing. Okay. I'm doing I'm looking at the docs right now. Transform. We want to transform using v2.compose. Six x series of 3 xy. All right, let's see if we can get any details on this. All right, so we're going to use lambda compose pipeline. We've got our width height. I'm reading the docs right now. 1 second. Chords. Oh, okay. Normalized. Okay. Should be 1. Yes, okay, looks good. Ensure the input is a tensor. We've got to make sure it's in tensor, which I'm pretty sure that a 2 tensor should be fine. So we're not far off. We are not far off. Hey, Bobo Bear, how's it going? Welcome on in. Happy Friday. We're currently reading docs. We're trying to figure out our favorite approach to encoding the input data for our AI model. And then once we do that and it looks good, then we're really good to see you. Really good to see you. It's great to have you here. We're running through the code right now, and we're really close to getting our first feed-forward unbroken graph in Pytorch. Because I've always been doing the encoding and decoding manually. So this time, though, we're going to do it in an unbroken fashion. And I'm going to use a compose encoder, which I am not used to. So we've got our 2 tensor. Let's start with this. This should not cause a break. Let's see here. And we're tracking click positions. All right, so that didn't break. Excellent. Excellent, excellent. Okay. Good, 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 good. Obviously, the 2 tensor is not tensoring. This does not seem to be tensoring. All right, I'm reading the docs here. How do we get this? Okay. All right. I feel like this should work just fine. I'm game width. Do we have the game? We do have the game window width. Print. Let's make sure that we have these things really quickly. We do have the data. Excellent. We've got the width and height. I mean, we could do this really, really ungood looking approach here. We could do this. I've got an idea. We could do this. How's it going, Aiden? We're good. We're trying our best to see if we're able to get an unbroken graph when we're encoding our input for the AI. Which code editor do you use? Oh, Pravan, we use Vim. Vim version 9175. Vim, there you go. It's really easy. Just regular Vim. Not NeoVim, just regular Vim. Okay. So I've got an idea. Yeah. Okay. Okay. That's my idea. It's not elegant, though I think it should be fine. That should work. That should be perfectly fine. Maybe we have to backslash all of these guys. It doesn't like that. Why not? Can I use Java in it? Sure. Yeah, absolutely. I do it all the time. I use Java. I use Vim and Java. I do. I edit Java files in Vim. I sure do. Okay. Why no likey? Why is it not like that? You can do that. It doesn't want it. Well, you know what we could do is we could just throw it all on one giant line and make it hard to read. I suppose we absolutely could. Okay. Better now? That's definitely not invalid syntax. Or is it? That seems fine to me. Yes. Is that all it was this whole time? Okay. So that'll work. Okay, great. Good. Although, boom, instant crash. Okay. Int object is not subscriptable. It sure is. I was just using it perfectly fine. See, it prints right here. Print. Okay. This might not be compilable as a thing. All right, so let's do 900 by 500. That's what we'll do. With 900. Height with 5. Was it 500? Yes, 500. Okay. Wait. What is this? Int object is not subscripted. It says it's an integer. So it's not what I wanted it to be. Okay. So that's the problem. All right. So this is, I believe, probably just a single. I would have you'd have it complicate by making a dictionary of each pixel with a pre-built flattened chord to reference pixels. See, that's, maybe we could. Maybe you're right. Maybe we could do that. Let me think about that for a second. Is that something that we can do? Yes. Okay. So I got it. I see maybe what's going on here. So my encoder features forward. Okay. I'm missing a step. So I almost did that. All right. So predictor features. This is, I'm figuring this out here. We are probably not going to be doing any batches, so I need to do this. So I forgot the batch. I basically forgot the batch is what I forgot. I have to try this out on incurses and library in C because I don't know Python really well. That sounds like a good project. Good idea. Code lengthens. Give it a try. Would give it a try. Okay, so I think So the jam, I'm pretty sure all I needed, I didn't do batching. So I'm doing the forward on a non-batch, and it's giving me every integer rather than the series. And I need it to give me the series. So I'm pretty sure this is what was the problem right here. So let me save that and run, and that should give us what I'm looking for. Yeah. It still didn't work. Why not? Int object not subscriptable. Is it not? Did I... Predictor. So that would be a forward on the features. Which perfectly fine. It's perfectly fine. La la la. What is it then? Let's try something really simple. Okay. So this before and after should never occur, like these guys here. So it's getting to a wrong spot for one. So that's part of the problem. Okay, so part of the problem is it's running the encoder before we have enough data. So it should have never gotten there. This should have caught it and immediately returned it. So print not enough clicks. Oh, it immediately got enough. Oh. Okay. So then what is print two clicks, 4 clicks. Well, 4 clicks is still not enough. Okay. I got it. Okay. Why is it... It's double counting it. So that's a problem. Oh, right. So that'll fix that part. And it needs to be 6. Or, well, 3, right? It needs to be 3. Okay. Perfect. Actually, we need 4 because we need to get the label output as well. So we don't have the labels yet. Okay. So we do need 4 here. Okay. One, 2, 3, 4, 5, 6. Okay, right. Okay, I see. One, two, three. Perfect. Okay, that's what I'm looking for. The Jam, you were self-taught over the last 4 years. When you keep track of your code so easily, it blows my mind. It's there's a lot to it. There's a lot to think about, and especially not a whole fully focused on it. So that gives us the data that we want on our input. So this will be the input series. We've got 3 XY coordinates for 3 clicks. The last click will be the label predicting the output or predicting the next position based on the 3 clicks. And then we just click around until the AI learns enough, and that's the idea. So with our feed forward with a batch, right, a batch size of 1 because it's just 1 feature input. So we need to do that. Now the lambda is very oddly, it's just taking one of the elements, and I need it to, because it can only support basic lists. It can't be an object or class or anything like that. So it has to be a list for the pipeline to not be a broken graph. Otherwise, it won't work. And so the part that I would like though is x. Let's see, can we do x comma y? Let's do what? Comma y plus 2. Let's do 10. Let's just see if that's possible. I don't know if we could do that. I'm going to see. I'm going to try it. Hey, Nathaniel, what's going on here? We're building an AI that's going to track the clicks and predict the clicks of a user. So you could do things like seeing if it's really human or if it's an AI, right? So you can see if there's organic clicks, and you can see if an AI agent that's driving a browser is clicking or if a human is clicking. You could do things like that. For now, though, we're just going to try to do predicting the next click. Something simple like that. All right, let's see if this works. I don't know if that'll work. Okay. So it doesn't like that because... So if it doesn't like that, how do we transform it properly? There is an option here that we might be able to use. Chords.view divide torch.tens. Where is our game width and height at? It was game. Okay, game dot. Here. This is what we need. We need this right here. Game width and height. Let's make it so we could read it on the screen, I think. All right, that looks good. And then we have to do a reshape. All right, so I'm not familiar with this code. This is just what the docs are saying. Okay, so that's readable. We can read that pretty easily. Let's double check this. Lambda x chords view -1 2 game width height, right? Because x comma y, and then reshape. Will that work the way I want it to? I think it will. Although I think we have to adjust some numbers here. Do you have any recommendations for learning torch transformers? Basically doing what we're doing right now. We've got a project and we've got a goal and we're trying to get it to work, basically. And that's the best way to learn, getting your hands on the keyboard. That's the best way. Otherwise, it's just asking the AI to do everything for you, and you don't really have to learn anything at that point. Though, if you are in the learning, I don't even know if what I'm doing right now, I don't even know if we have to keep doing this anymore. Like, seriously, like, do I have to keep learning these kinds of things, or does the AI just take care of everything for us going forward? Right? It seems like the latter, doesn't it? Doesn't it seem like the AI is going to take care of everything for us? But I do have to get going. I'm like way over time. So this will be, if we get this working right here, it's just the encoding. We're wrapping up. We're wrapping up. I have to change some stuff to get that to work right. AI underscore point list append. We have to redo this like this. Like this. Y. That. AI point list. Now it's going to be bigger. So we need to do 6 and 2. Like that. Number of clicks. It's like not. It's no longer number of clicks. It's number of points. Okay, that should be it. That should be it. It will, especially when they make the big transformer, large language model breakthrough. That's definitely coming, is it? It feels like, I know, it feels like we're really close. If not today, like already with the existing tech, it seems like it's already good enough. Syntax error. Okay. Are we good now? I don't know. Oh, darn it. If needs transfer, else input. Clearly, my lambda's broken. Clearly, my lambda's broken. All right. We're going to have to, we'll have to, I have to get going. But we got really close. I know that's the problem right there. I mean, that is definitely a problem. It's because that won't cause any errors when I run this, right? Yeah, so no errors. Wait. The before and after is not big enough. Okay. We're missing numbers. 1 second. Why are we missing numbers? 258. Okay. That's why we're missing numbers. Okay. Much better. Okay. Okay. It's great to see your problem solving. Thanks for doing this. Yeah, no problem. We'll make our way through this. All right. So this is the problem line here. Obviously, if we undo this, that'll work perfectly. Will that work though? I don't even know if that'll work. No, that won't work. That won't work. It'll only work if I do this. If I do it like this. That definitely works. That is a transform with an unbroken graph. As you can see here, that absolutely works. The before and after is +1 on every element in the field. So we're correct. But I need to get it to work. There is extra stuff that I'm missing here. There's a v2 dot lambda x torch dot as tensor d type equals float 32. Float 32. Okay. So that part was there. I wonder if that part will work. Let's see if that part works. I'm missing a comma. There we go. Breaking. Nope. It does. Okay. Okay. Yep. Okay. The output finally is transformed. It's finally transformed. My goodness. My goodness. Finally transformed. Okay. So we made progress. We won't be able to finish today, though. Can we do this? Let's get rid of that. Will that part work? Will this part work here? Nope. Okay. All right. So this is going to be our task for next time, is figuring out how to transform essentially our encode, or so that way essentially we create our vectorization of our XY coordinates. So this is the part that we need to solve next time. So I'm going to add a to-do here. To-do, fix this. All right. This is for next time. So I will make a git repo init. Let's see, nn for click future predictions. Not finished. Good progress, though. All right. Excellent. And I'll make a repository for this. GitHub. And then we will have to resume this on Monday is what we're going to do. We're going to resume it on Monday. New repository. Okay. Steven. Best viewers. Okay. We'll call this click prediction AI. Predict the user's next click XY coordinate. I think that's it. Public looks good. Okay. Copy. Future. Push. Everything's up to date. All right, there we go. Repository, good to go. All right, I'll throw this so if anyone's interested. This is where our current progress is, and we will resume on Monday, and that'll be the plan. So I'll put it over here. There we go. So that'll be the plan for Monday. This could be so good, used as a cheat for FPS games. It would, yeah, exactly. You can absolutely do this. So you'd probably want to use a vision transformer or a convolutional neural network to look at the screen as the input, capture. Probably what you do is like an aim assist. So you'd capture just the pixels near to the cursor where the player's current cursor is on the screen. And then it will look to see if there is a point where, like, I guess the other players, the enemy players, if there's a place to adjust the cursor pointer for headshots, for example. You could do that. So you're right, though, the Jam. This is like the precursor to that. This is the precursor. Some additional introductions. All right, there you go, everyone. Thank you for joining today. We'll be back on Monday. We'll be continuing. Hey, Steven, how's it going? Milik, good. How's it going, Milik? We're leaving. We're headed out now. The Jam, thank you for hanging out and spending time with us. We'll be back on Monday. We'll focus on getting this AI prediction to finish the encoding. You have a good weekend, too. Thank you. All right, everyone. Have a good weekend. We'll be back on Monday. See you guys.